Hello students, how are you? I hope you are doing well. Okay, so we are here with the question discussion of AIT 4 JEEs paper. Okay, so I have selected some problems in which I think you find some problem. So I am solving it down for you for the better understanding of yourself. Okay, so let's just get started. This is the question number 1 here. The Nitin is a very naughty boy while in an elevator which is moving up with an acceleration of 6 meter per second square. He throws chewing gum to make stick at the ceiling of the elevator. He throws the chewing gum with a speed of 8 meter per second with respect to the lift. Okay. Now what should be the minimum height of the elevator so the evil plan doesn't get executed? This question is directly from the relative motion, you can say. Okay. So firstly, because we have to deal all the situation with respect to lift, and lift is not stationary over here. Lift is also moving with an acceleration of 6 meter per second square. So we need to find out what is inside the lift, what kind of acceleration this chewing gum has facing. Okay, so we need to calculate the A effective. Okay, which is, you will see this is the acceleration of lift A. Now the gravitational acceleration is acting downward, so it is A plus G. Both vectors are opposite in direction, so they will add up, and the net effective acceleration will be in downward direction with A effective on the chewing gum. So it is 16 meter per second square because A is 6, G is 10. Now we need to calculate the S. Okay. So what will be the minimum height? When it attain the maximum height, the velocity at that point will become 0. So we are going to apply the third equation of motion, which is V square is equals to U square minus 2A effective into S. Now, what is this V? V is going to be 0. U square we have provided 8 meter per second with respect to lift. This equation we are applying with respect to lift. Okay. So it is 0 equals to 8 square minus 2 times A effective means, what is meaning of A effective? We have 16 into S. So S here is 8 into 8 divided by 2 into 16, which is result in 2 meter. Okay. So A is the correct option. Okay. I'll move on to the next question. Yeah. A smooth uniform rod of length L and mass capital M has two identical beads, 1 and 2, of negligible size. I am pointing down it, negligible size. Each of mass M, which can slide freely along the road. Initially, the two beads are at the center of the road and the system is rotating. Are at the center of road initially, and the system is rotating with an angular speed of omega naught about an axis perpendicular to the road, and it is passing through the midpoint. Now there are no external force. When the beads reach at the ends of the rod, the angular velocity of the system you have to calculate. Since in this question there is an information, there is no external force. So if there is no external force, we can conserve the momentum. Which momentum? The linear. If the force is if no external force is there, since there is no external force, so there will be no external torque. Okay, so we can conserve the angular momentum also. So by conservation of angular momentum, initial, L initial is equals to L final. L initial for beads plus L initial for rod equals to L final for beads plus L final for rod. Okay. Now, what is the formula for L? L is nothing but moment of inertia with angular velocity. Okay. So here, L initial for beads. Initially, the two beads are the center of the road. So these beads are at the center of road and they have negligible size, which means you can you can assume that present on the center. So the moment of inertia here, I will be 0 because it is presenting on the line of the rotation. So the mass present on the axis of rotation has 0 moment of inertia. So the initial moment of inertia will be 0. Initial angular momentum will also be 0. Then what about the initial momentum for rod? So rod is rotating about its midpoint. So midpoint ke about what is the moment of inertia? It is 1 by 12 ml square. Okay. So it is 1 by 12 ml square is equals to what is the final position mein beads are at the end point. So you can assume this is a system of mass present at the end of length of L by 2 and L by 2. This is mass m, this is also mass m. Okay. So you can simply calculate this as 2 times of mass into the distance ka square, which is L by 2 ka whole square. Plus I have written it for both the beads. Final load will be also same, and it is also written as with omega naught. Initial velocity will be omega naught, and this whole system finally will be rotating with a angular velocity of omega, let's say. So 1 by 12 ml, capital ML square is equals to into omega. Okay. Now we just have to solve this. It is 1 by 12 capital M L square omega naught equals to 2 times small m L square by 4 plus capital M L square by 12 into omega. We can take L square common and we can cancel it out. 2 2s are 4, we can cancel out. So in the next part, it is 1 by 12 capital M omega naught is equals to small m by 2 plus capital M by 12 into omega. Okay. You can take 1 by 2 also common. So it will become 1 by 12 capital M omega naught equals to 1 by 2 small m plus capital M by 6. We have taken 1 by 2 as common. So this 2 will cancel this out. It is 6 times m now. Take the LCM over here. What you will get? It is 1 by 6 capital M into omega naught is equals to 6 small m plus capital M divided by 6 into omega. 6 and 6 goes cancel out. You have to find the value of omega. So put this term in the LHS. So it is capital M omega naught divided by 6 times small m plus capital. Okay. So this is the final answer you have. And this is option number 8. Okay. Now this this question is from laws of motion, and it is a problem of block over block. Okay. So in this types of problem, firstly you will have to find out that what is the value of friction and which block only the frictional force is acting. Okay. So this is our 10 kg block and this is our 40 kg block. There is no friction between ground and the 40 kg. Okay. But there is a friction. Mu is equals to 0.4 is given. Okay. And there is a 100 Newton force is applied on the upper block. Okay. So if this 100 Newton force trying to pull this block in this direction, so a friction will try to oppose this and act in this direction on 10 kg block. So FBD, if I try to draw the FBD of 10 kg block. So this is our 10 kg block. 100 Newton force is applied here. There is a normal reaction provided by this surface, the contact surface. And there is a mass, which is the gravitational force, which is 10 times G. mg, m ki value has 10, with this 10g. And there is a friction also. F. Now, if I try to write the equation for it, for friction, if I want to calculate the friction force, It is mu times N. Okay. So frictional force is mu is 0.4. What is the value of N? N is equals to 10 G. So it is nothing but 40 Newton. This frictional force. Now we are interested in the acceleration of lower block. So this is 40 kg block. There is a force acting downward, which is the gravitational force, which is 40 times G, weight of the block. There is a upper side reaction like N dash, and there is a reaction. There is also a reaction by this block 10 kg, which is acting downward, and which is exactly equals to mass of the upper block multiplied with gravitational acceleration. Now, if the friction on the upper block acting in this direction, so for Newton's third law, an equal and opposite force will act on this block. So only frictional force is present. This is the block I'm interested in. Now, if this block has an acceleration in this direction, so what should be that? For second block we are doing, it is F is equals to ma according to Newton's second law. F is mu n, and we have already calculated the value of friction. It is 40 times Newton, 40 Newton. Mass is taken as 40 kg. So it is 40 into G equals to A, acceleration. Okay. So you have, sorry. So 40 times ma, mass is only there, na? So 40 will come. 40 is the mass of block. So acceleration here is 1 meter per second square. So option D is the correct option. So in this question, what we have done, we have figured out on which block only the friction force is acting. We have already calculated the value of frictional force, and then we just equate it with mass into acceleration equation and find out the acceleration. Got it? Now, yeah. A spring is first stressed by an amount A, then further stressed by an amount B. If the force constant is K, then what is the work done in second stretch? So let me show you. Let's say this is our spring and in the natural length. Okay. So there is no force acting on it. Now it is first stressed by an amount of A, let's say. Okay. So there is a force, acting. Try to pull the spring in the natural position. So there is a force which is K times A, because force on the spring will be Kx. So K times the value of stretch, which is A. Okay. Now, again, it is stretched by an amount of B. So now the total force is acting on the block is K times the total stretch, which is A plus B. Now, solution is, we know that work done in spring to stretch it by an amount x is equals to 1 by 2 times k x square. So what we are going to do, we have to find out the work done in second stretch. So work done total here is work done in first stretch W1 plus work done in second stretch. We know the work done total because we know the total extension, which is A plus B. So it is according to the formula mentioned in equation number 1, which is K times A plus B whole square equals to work done in first stretch. It is K times A. So 1 by 2K. What is the value of a stretch? It is A. So A square plus W2 we are interested in. So W2 is equals to 1 by 2 times K we have taken common. It is A plus B square whole square minus A square. So W2 here is 1 by 2 times K into A square plus B square minus 2 plus 2AB minus A square. A square and A square got cancel out. So work done total is, you can take B as common. So it is 1 by 2 times KB B plus 2A. Or you can arrange it like your answer. It is KB divided by 2 into 2A plus B. So this is the work done in second stretch. So it is 1 by 2 times KB into 2A plus B. So option B, C is correct option. Now move on to the next question. This question is from rotational dynamics and from the topic of center of mass. Now, solution of this question we are going to find out. Whenever this type of question comes to you, in which there is a cavity and the question is asking about the center of mass of shaded portion. So in this type of problem, what you have to consider, you have to consider the cavity as negative mass. Okay, negative mass. Now, what is the formula for center of mass? This is a planar object. So formula for planar object is x center of mass is equals to area of 1 multiply the x1 coordinate of first center of mass plus a2 x2 divide. Here we have two object only. So we have taken 2 a1 plus a2. Okay. Initially, if you will see, this is the sphere that we have, disk, the planar object. At A, we have considered the origin. Okay. This is 0, 0. So if there is no cavity, so what should be the center of mass of this object? This disk will be at 0. Means x1 is equals to 0. x1 is the center of mass of this object. Now, there is a cavity which is present here at, and this cavity has a radius of r by 4. So this distance is also r by 4. So the diameter of disk will be r by 2, and this total distance is r. So this remaining distance is r by 2. Okay. So now the center of mass of this disk from this origin will be, look in this figure you will understand. This distance is r by 2. This is r by 4 and this is also r by 4. So center of mass present at the center of the disk. So it is at r by 2 plus r by 4. So x2 is equals to r by 2 plus r by 4, which is equals to, you take 4 as LCM. So it is 3r by 4. This is the value of x2. Okay. But you have to consider this cavity as the negative mass, which means you have to take this area as the negative one because it is shaded out. It is taken out from the complete disk. So x center of mass is, what is the area of this complete disk? This is pi r square into, what is the value of this x1? It is 0. So this will become 0. Minus would come the area of second. This disk will be pi r by 4 square multiplied by the distance, which is 3r by 4 x2 divided by pi r square plus pi r square by pi r by 4 ka square. Area of 1 plus area of 2. Now x center of mass is minus pi, you can cancel out by taking common. So here you are with r square into divided by 16 or let me do in the next page. So it is x center of mass here is minus r by 4 whole square into 3r by 4 divided by r square plus r by 4 का whole square. We have taken pi as common and cancel it out. Okay. Now x center of mass is minus r square into 3r divided by 16 into 4 divided by, you will take LCM as 16, so it will be 17. 16 plus 1, it is 17 r square divided by 16. 16 and 16 got cancel out. This r square and this r square will cancel out. So it is x center of mass here will be, this 17 will come this side. This is 3r by 4 minus 3 times r by 4 into 17. Okay. Look, there is no terms left here. There is no term left here, na? Okay. So if you will also see this, it is minus r square into 3r divided by 16 into 4. Okay. 4 plus square is 16 into 4. Multiply with 16 divided by 17. Oh, there is a mistake that we have did. We have to take this also minus because it is a negative mass. Okay. So that is why this term would appear as, 16 minus 1, which is 15. Okay. So it is, just a second, you can do it here. So it is r square divided by 4 square, which is 16, multiply with 4 divided by, it is 15 times r square divided by 16. You can take it as minus r square into 3r divided by 16 into 4 multiply with 16 times 15 into r square. This 16 and 16 will cancel out. This 3 5s are 15. R square and r square will cancel out. So it is minus r by 20. This minus representing that you have to move origin to left. Okay. So the correct option is r by 20 to the left of A. Okay. Move on to the next question. Yeah. This question is also from rotational dynamics. So in this question, a rod is given to you, okay, which has mass m, and it is released at just shown in the figure. So this point, it is released. So it will rotate about this point. This point behaves as a hinge to this point. Okay. Now find the initial angular acceleration of the rod just after release. Just after release. So when it's released, okay, when this rod becomes released, so there is a force, gravitational force, mass of the weight of the rod will acting downward, which is nothing but mass into gravity. And this, if you release this, this is the only force which is responsible for the rotation of this. Okay. This angle is 37. Okay. So you have to calculate the torque. Okay. Because we know that torque is equals to I times alpha. Okay. Now, if you resolve this mg into this direction, this angle is also 37. So it is mg cos 37 and it is mg sin 37. So the torque provided by, here we have two component of force, and this is our axis of rotation about. So this mg sin 37 is passing through the center of rotation. Okay. So this have no torque. No torque. Only the force which is perpendicular to the line of rotation contribute in the torque. So this mg cos 37 is the responsible for the torque. Okay, and it is applying on the length L by 2, just half, because center of mass present in the half of this. So this is L by 2 and L by 2. So torque is nothing but F cross R, which is F R sine theta, and R sine theta is the perpendicular distance, or you can say F sine theta multiply with the distance perpendicular to it, I times alpha. F sine theta is the perpendicular component of force to the axis of, to the line passing through the axis of rotation. Okay, I times alpha. So F perpendicular here is mg cos 37 multiply with R, which is L by 2. Now, the rod, when it rotates about its end point, so the moment of inertia of this system will be, when the rod rotate about its one end, it is 1 by 3 capital M L square. So 1 by 3 capital M L square into alpha. This M and M got cancelled out. Okay, now in this triangle you will see this length is L by 2. Okay, this angle is 37. So what is the value of cos 37? Cos 37, you must aware of that triangle in which this 37 minimum angle is there. So this length will be 3 and it is 4, and this length is the maximum 5. So this angle would be 37. This angle would be 53. Okay. So from this triangle you can calculate cos 37 is 4 by 5. So it is g times 4 by 5 multiply with L by 2, which is nothing but L by 2, same, 1 by 3 times L square to alpha. 1 power got cancel out with L. So it is 2 and 2 got cancel out. So it is 3 times 4 G divided by 5 into this L, okay, equals to alpha. And there is another remaining 2 over here. There is also 2. So this present here, this 2 will cancel out this 2 times. So alpha here is nothing but 6 times G by 5L. Okay, got it? I hope you got this. So option B is the correct option. We have taken torque by the force perpendicular to this line, perpendicular to the line which is passing through the center of rotation. Okay. Now move on to the next question. Yeah. It is a question from work, energy and power. Solution of this question. N identical beads are resting on a smooth horizontal wire which is circular at the end with radius r is equals to 0.5 meter as shown in the figure. Find the minimum velocity which should be imparted to the first bead such that the nth bead will fall in the tank after completing full circle in the vertical plane as shown in figure. Take all the collision between the bead elastic. So E is equals to 1, which means the velocity that I have imparted, if there are two masses, this mass has a velocity v and this system has collided, then this will also have the velocity v for elastic elastic collision. So for elastic collision, V final is also equals to V initial. Got it? So this is the information provided to us, which means this is the system that we have, and here are the beads and beads. Okay, and this is the bed. So if I provided the velocity v to the first bead, so this velocity will purely impart it to this nth bead. This nth bead will also move with velocity v. Why? Because of elastic collision. Elastic collision. Okay. Now, this is a very simple question from now. This velocity is v. So what should be the minimum velocity at the bottom point to complete the circle, to complete full circle, which is v. It should be greater than equals to root 5g r. So what should be the minimum value of it? So v minimum here is equals to root 5g r. Now 5, what is the value of g? It is 10. What is the value of r? It is 0.5. So it is square root of 25. So v minimum is 5 meter per second that you have to impart to the first bead. Okay. Now move on to the next question. This is a very important question also, and it is from same a oscillation part. Okay. So the solution of this question. Yeah. So in the below shown figure, a simple pendulum is suspended from a peg on a vertical wall. The pendulum is pulled away from the wall to a horizontal position and released. The ball hits the wall and the coefficient of restitution between ball and wall is 2 by root 5. Okay, so the collision is taking place with a coefficient of restitution 2 by root 5. The minimum number of collision after which the amplitude of the oscillation become less than 60 degree. So we will calculate it for 60 degree. After that, it will become less than 60 degree. Okay. Now, so this is the length L. This is length L. And this is the horizontal position of this. Okay. So let's say for 60 degree amplitude, it is at this point. It is taking rotation at this point. This is the angle 60 degree over here. Okay. Now, this is also this length we have to interested about. This length is also L. This length is also L. This is our reference line because we are going to apply the conservation of energy here. So we have to decide a reference line for potential energy. So this is our reference line. So if I talk about this system, now this L has a component in this direction and this direction. So this direction is L cos nothing but L cos 60, which is L by 2, because L cos 60 is nothing but L by 2. So this distance will also become L by 2. Okay, got it? If I connect this point to this point, you will see this length is also L, this length is also L. So this length must be L. The three lengths are equal, so this will become a equilateral triangle. Equilateral triangle. Okay, so in which this angle is also 60 degree, this angle is also 60 degree. Got it? So now if I talk about the initial position, let's say this initial position. Initially, this is, we have kept it here from a height L. So when it comes down at the minimum point of it height, it will have some kinetic energy. Now it is at the first extreme of it. This is the second extreme of it. It is the extreme position. So at extreme position, what is the formula? The kinetic energy is equals to potential energy. Whatever the potential energy have at the extreme position, this will imparted in the kinetic energy of this system finally. So kinetic energy of initial will be equals to potential energy of initial. Okay. So, or you will say kinetic energy of final at point. Let's say this point is B. So kinetic energy of point B is equals to the potential energy of point A. So kinetic energy of point B is 1 by 2 times m. Let's say it is u square, the initial velocity first for the first collision, is equals to what is the potential energy? It is mg times height, which is L. mgl. So from here you can say this m and m got cancelled out. So u square is equals to 2g capital L. So u here is equals to square root of 2gl. Now, from the knowledge of continuous collision, you must have remembered this formula that velocity after nth collision, I will write it as velocity after nth collision will be Vn is equals to e raised to the power n into velocity at first collision. So this is equation number 2 and this is our equation number 1. Now we have to find out the final velocity, which is at the 60 degree. We have to calculate. So at this point also, the potential energy of this point, let's say this point is P. So the potential energy of P is also equals to the kinetic energy finally at this point. Okay, because it is rotating in this direction. It is kept on doing this simple harmonic motion in this way. So potential energy of this point A should be equals to the potential energy of this point B should be equals to the kinetic energy of this point. Let's say this point is B again. Okay, now it is going like this because this amplitude is decreasing. Okay, so here potential energy at point B will be mg into height above from the reference line. So it is at L by 2. It is L by 2. 1 by 2 times, let's say, velocity after nth collision we are interested. Okay, so it is Vn square. Okay, this m and m got cancelled out. So this Vn square is equals to 2 and 2 will be cancelled out, square root of gl. This is equation number 3. Okay, take this value of Vn and u and put this in equation 2. So Vn we have as root gl, u we have as root 2gl, and we have an equation that Vn is equals to e raised to the power n. N is the number of collision here into u. Put the value of Vn, which is root gl, equals to e raised to the power n into root 2gl. Now e raised to the power n equals to root gl over 2gl, 2gl. Okay. Now if you calculate this gl and gl will cancel out. This e raised to the power n here is nothing but 1 by root 2, or you can say e raised to the power n 1 by 2 raised to the power 2. Okay, got it? So here in this question, what you are going to do, you are going to apply the logarithmic. Okay, so in this situation, what we are going to do is we are trying to calculate, we are taking the log on both sides. Okay. Okay. So we are going to take the log on both sides. So when we take the log, ln we are taking. ln is basis. So it is n ln e is equals to ln 1 by 2 raised to the power 2. So from here, the n is approximately come as 3.1. So you will take, it is equals to 3.1 something. So we'll take n approximately as 4. So the number of total collision will be 4. Okay. In this question. Now move on to the next question. Yeah. So move on to this question is, two block B1 and B2 of mass M1 and M2 respectively are connected with the help of a pulley and string as shown. So the upper surface of vehicle is smooth, but vertical surface is rough. Okay. Given that A is G by 7, this bogie is also moving with acceleration G by 7, and the mass M1 is equals to 7.5 times of M2. Now the coefficient of friction between block B2 and side of vehicle is n by 10. Then find the value of. So this is the question from non-inertial frame of reference. This surface is rough and this surface is smooth. Okay. Now this bogie is also accelerated with an acceleration. Okay. So this bogie is also accelerating. This is the block we have. This is tension. String is there and this is another block. This is block M1. This is block M2. Okay. Now this bogie is moving in this direction with an acceleration. We sit on the bogie and try to observe the motion of these blocks. So we are in the non-inertial frame of reference. So it is a non-inertial frame of reference. Okay. So in this block, if I try to draw the FBD of M1 block, this is M1. There is a tension T here and there is a force which is M1 times A, which is termed as pseudo force. Pseudo force, which is equals to mass of the system multiplied by the acceleration of the frame. Okay. So here you can say that this tension, because there is no friction in this surface, so this tension is equals to M1 times A. This is equation number 1. For block M2, this is the surface in contact. Okay. This is the mass multiplied by G acting in the downward direction. Upward direction may we have tension. This block tension. This is mg. Now the normal reaction is here provided by this contact surface. This contact surface. So this normal reaction would act in this direction, and let's say this normal reaction is n. Okay. Now the friction is there, and if this block is trying to go upward, so the friction will act in this direction. Okay. So here you can write it as T is equals to F plus M2G. Now this F is friction force is equals to mu times N. Mu times, what is the value of N? In this block also there is a pseudo force acting in this direction, in the opposite to the direction of motion, which is equals to M2 times acceleration of the system. So this N is nothing but M2A. M2A. Okay. So T here is mu times M2A plus M2G. This is equation number Now, we would have to just compare this. So T is equals to M2A plus mu M2A plus M2G. Mu M2A plus M2G. And tension we have from first equation, it is M1A. So M1A is equals to mu M2A plus M2G. This M1 is equals to, given in the question, equals to 7.5 times of M2. For this value, 7.5 times of M2 equals to mu M2A plus M2G. M2 and M2 would cancel out from both the sides. Put the value of A also. So it is given you as G by 7. So it is G by 7 equals to mu times G by 7 plus G. G and G will also cancel out. So you have 7.5 divided by 7 equals to mu by 7 plus 1. Okay. So what you will do, take mu by 7 separate, put this 1 on the LHS side, 7.5 by 7 minus 1. So you will have mu by 7. If you take the LCM, 7.5 minus 7 is 0.5 divided by 7. This will also cancel out. So mu is here at 5 by 10. Because in this question, mu is given to us as in the form of n by 10. So if you compare this by n by 10, this 10 and 10 will get cancel out. So n you have as 5. So this is the answer to that question. Okay. Now, this is the question from the projectile motion in plane. Now, in this question, a commander fires a shell at a certain angle of the projection from point A, which clears the building, which is in cuboidal shape of dimension 20 cross 15 cross 12.5 meter cube. In its diagonal plane, shell just clears the roof diagonally and point at point P and Q and falls on the other side of the building at B. Makes angle 45 with horizontal at P and Q, shown in figure. If the range AB of the shell is n into root 3 meter, then find the value of n. Now, in this question, if you will see, on the upper part of this cuboid, you will see this is a cuboid you have. Okay. This is the cuboid you have. This angle is 45. This angle is also 45. Now, the motion is starting from here. This is point A. Let's say the velocity initial will be u, and it is at angle theta. So this component, I have considered this as x-axis, and this is at y-axis. So this component will be ux, and this component will be uy initially. Now we are interested in the range, which is AB. AB is equals to question mark. We have to interest. This diagonal length you can calculate. Okay. And this diagonal length, if you will see this upper projectile motion on, this will also act as a projectile motion in which the velocity I have considered v. Let's say the velocity is v here, which also has a component in this direction, which is vx and vy. This is the range of it, r dash, let's say, which is nothing but pq. Okay. Now, if you will calculate the range of this projectile, PQ, upper projectile motion, this projectile motion, you will see you can apply the formula here also. For PQ, you will apply the formula for range. which is the velocity here is v square sine 2 theta divided by g. Theta you have provided with 45. So 2 theta will be 90 and sine 90 will be 1. So r dash you have as v square by g. Now r dash is nothing but the diagonal of this cube. And if you focus on this triangle, let's say this point is S. So if you focus on this point is, let's say, P dash Q dash. So in triangle P dash S Q dash, this diagonal behaving as a hypotenuse, perpendicular and base known to you. So you will calculate this R dash. So this R dash is nothing but square root of 15 square plus 20 square, which is 225 plus 400. It will give you 25. So from here, this is 25 multiplied by g equals to v square. So v is here equals to 5 root 10 meter per second. This is the first information that we got. Okay. From this equation, we can say that Vx is v cos 45, and we have calculated earlier, which is 5 root 10 multiplied by 1 by root 2, which is 5 times square root of 5. Okay. This is Vx, meter per second, and Vy will be V sine 45. So same formula, same value we will get, which is 5 root 5 meter per second. Now for projectile motion, motion ux is always constant. Ux is taken as constant because there is no acceleration in horizontal direction, no acceleration in x direction. So ux remain constant. Initially we have assumed that the velocity of the projectile will be ux, which is equals to Vx from this concept, and Vx we have calculated as 5 root 5 meter per second. Now, if we calculate the value of Vy, so Vy, we can apply the equation of motion, second equation of motion. Vy square is equals to uy square minus 2ay times y. In this you will see we are interested in finding the velocity of y direction at point P. The point P has a height of sy we have as what? Sy here is 12.5. This length. Okay. So we are applying it here. This Vy square is equals to minus of 2ay sy. Now Vy square we know. Vy square is 5 root 5. 5 root 5 square. Uy square we are trying to find out. Minus 2 times ay is 10 and sy is 12.5. So it is 25 into 5 is equals to uy ka square minus, it is 125 multiplied by 2 is 250. And it is 125 again. 25 5 is 125. So uy square you will have 250 plus 125. So uy square is equals to, it is nothing but 375. You can write it as, if you divide it by 3, it will be 125 multiplied by 3. Or you can say it is 25 times 5 into 3, which is 15. So uy you have as 5 root 15. Okay, this is meter per second. So you have both the values, ux and uy. Now there is a formula for range, which is 2 times of ux uy divided by g. You can also calculate it like this. R is equals to u square sine 2 theta by g. So u square, you can take it u sine 2 theta is 2 sine theta cos theta. So 2 is here. It is sine theta, and 1 you will take as cos theta with cos theta. So u sine theta is nothing but uy. U cos theta is nothing but ux. Okay. So from here you will say that R is nothing but 2 times ux into uy divided by g. Okay. So you know the formula, how it is come. Now, if you will try to calculate the value of range, so range here is 2 times, what is the value of ux? Ux is 5 root 5. 5 root 5. What is the value of uy? It is 5 root 15, or you can say 5 root 5 into root 3 divided by g, which is 10. So 2 5 are 10, 5 5 cancel out. So this equation will become root 5 and root 5 will become 5, and there is another 5. So 5 5 are 25 into root 3. Now in question, it is given you that range AB is n times root 3. So if you will compare it with n times root 3, this root 3 will cancel out. So n is equals to 25 meter. Okay. So this is it. I hope you are clear with this. Now, solution of this question will be, find out the angular velocity of the disk if disk is confined to roll without slipping at point of contact. The radius of disk is 5. So this disk is confined to roll without slipping. Okay. So this is the condition that is given to solve the question. At the point of contact, let this is point P and this is point Q. So if you draw this point P, because this is rolling without slipping, so it has a velocity in this direction, which is 10 meter per second, exactly equal to the velocity of this plank, 10 meter per second. This is point Q, which has a velocity of 20, just double of it, 20 meter per second. If you join this line, and you will join this line, okay, so velocity about this point of intersection will be same. So angular velocity of this disk about this point will be same. So here you will say that if this is point P and this is point, let's say R, so this is, so you can say that PR plus QR here is nothing but the diameter, which is 2 times the radius of the sphere. Okay. If you will calculate the angular velocity, because it is rolling without slipping, so angular velocity of each of the every point in contact will be same. So angular velocity of point P, which means it is omega times Vp is equals to omega times R, and R here is nothing but the radius. No, it is PR. Okay. So Vp you have given 10 equals to omega times PR. Okay. This is equation number 1. Now, the second equation will be for point Q. So VQ is equals to omega times Qy R. VQ is 20 omega times QR. This is equation number 2. Now take the ratio of equation 1 with equation 2. So it is nothing but 1 by 2. 10 by 20 is 1 by 2. PR by QR. From here you will see that QR is equals to 3 times of PR. Okay. If you put this value, put this in equation what? It is to be put in equation number 1. Okay. Now put this value in equation number 1. What you will have? PR plus 2PR is equals to 2 times of radius, which is 5 meter. So 3PR you have 3PR equals to 10, or PR is equals to 10 by 3 meter. Now put this value in equation 1 or equation 2, you will have the value of omega. Put it in equation 1, we have omega times PR, which is 10 by 3 equals to 10. So omega we have as 3 radian per second. Okay. So this is the solution to this question. I hope you got the solution of this question and you have the conceptual understanding of this also. Okay. Thank you so much for being attentive in this session. Thank you so much.